Welcome to a crucial chapter of your journey towards acing your elementary teacher certification exam. Today, we'll discuss the world of engineering practices. By the end of this lesson, you will learn to explore how you can guide students in defining and contextualizing problems, making learning interactive and impactful. Discover the art of teaching students to develop and use models. You'll also learn how to plan and execute scientific investigations. Enhance your readiness for computational thinking. Learn to facilitate evidence-based discussions. We'll also cover how to effectively communicate research findings. Gain an understanding of key material properties like flexibility and ductility. You'll learn to identify design problems and communicate solutions. Apply criteria and constraints in the design process. Select appropriate tools for engineering tasks. And finally, you will master teaching the iterative nature of the design process. Let's get you totally prepped for test day so you can ace the engineering practices section of your exam. Now, let's shift our focus to the need-to-know vocabulary terms essential for mastering the engineering practices section of your teacher certification exam. Here's a list of key terms you'll need to know. We'll go through each definition one by one. I encourage you to pause the video, try to match the correct term with its definition, and then hit play to check your answers. Defining problems, identifying a need or challenge that requires a solution. Using models, employing physical or conceptual representations to explore and test ideas. Scientific investigations, a systematic process to explore phenomena involving observation, experimentation, and data analysis. Interpreting data, analyzing information gathered from observations or experiments to draw conclusions. Computational thinking, using computer science concepts and skills to solve problems and design systems. Designing solutions, creating answers to problems through careful planning and testing. Argument from evidence, justifying conclusions or decisions based on data and observations. Communicating information, sharing and discussing information effectively with others. Flexibility, as a material property, the ability of a material to bend without breaking. Ductility, the capacity of a material to stretch thin without becoming weaker or breaking. Thermal conductivity, a measure of how well a material can transfer heat. Electrical conductivity, a measure of how well a material can allow the flow of electric current. Melting point, the temperature at which a solid material turns into a liquid. Criteria and constraints, the requirements and limitations that are taken into account when designing a solution. Measuring tools, instruments used to determine the size, amount, or degree of something. Hand tools, tools operated by hand and not powered by electrical or mechanical means. Iterative design process, a cyclical method of prototyping, testing, and refining a product or process. Testing solutions, the action of putting a design to the test to evaluate its functionality. Analyzing impact, assessing the effects and outcomes of a solution or decision. Iterative improvement, the process of making incremental refinements and enhancements to a design or product. Now, let's dive deeper into the engineering design processes tailored for your teacher certification exam. We begin with defining problems. Imagine teaching your students to identify real-world issues, such as designing a bridge to help animals safely cross a busy road. Help them clarify the need by discussing who is affected and why the problem needs a solution. Understanding the context is key to meaningful engineering projects. Next, encourage your students to develop and use models. Guide them to create models that represent their solutions, teaching them to predict the outcomes of their designs. Planning and carrying out investigations is crucial. Encourage experimentation and record observations to see how different materials affect their model's performance. Analysis and interpretation of data come next. Show them how to use simple graphs or charts to make sense of the data collected and help them draw conclusions about what their data means in relation to their problem. Incorporating mathematics and computational thinking is essential. Teach them to measure and calculate effectively to predict materials needed and outcomes, helping them recognize patterns in data. Constructing explanations and designing solutions is where creativity meets critical thinking. Guide them to use their data and research to propose solutions, encouraging peer feedback to refine their designs. Engage students in argument from evidence. Facilitate discussions where they present their models and data to support their design decisions, teaching them to critically evaluate their own and others' solutions. Finally, obtaining, evaluating, and communicating information are fundamental skills in any engineer's toolkit. Show them how to gather information from various sources and communicate their findings effectively through presentations and written reports. By mastering these processes, you empower your students not just to solve problems, but to think like engineers. This is the kind of answer you'll want to be looking for when completing your exam. Next, let's explore the fascinating world of materials and their properties. Understanding the relationships and uses of materials like metal, plastic, and wood will help you effectively convey engineering concepts to your students. Metal is known for its high thermal and electrical conductivity, but is often heavy. Plastic, while generally flexible and with low thermal conductivity, offers varying durability. Wood, excellent for structures, provides variable strength and is a poor electrical conductor. To teach these concepts, you'll need to understand key terms. Flexibility, for instance, describes how much a material can bend without breaking. Ductility refers to a material's ability to deform under stress without breaking, like stretching copper wires into thin strands. Thermal conductivity measures how well a material can conduct heat, crucial for materials used near heat sources. Electrical conductivity is the ability of a material to carry an electric current. Melting point, the temperature at which a solid becomes liquid. Moving forward, identifying and communicating design problems is essential for mastering your exam. Look for answers to your multiple-choice questions that require your students to explain their solutions. In every project, make sure you identify answers on your exam that define criteria clearly. Selecting the right tools is next. From measuring tapes to screwdrivers and child-friendly power tools, look for answers to the multiple-choice questions that emphasize safety, accuracy, and quality. Finally, the iterative design process teaches that engineering is never static. Be on the lookout for question selections that support student testing and collaboration with real-world projects in the classroom. With these tools and knowledge, you're well on your way to passing your certification exam and becoming a proficient teacher of elementary engineering. Remember, every lesson you teach builds the problem solvers of tomorrow. As we wrap up, it's time to put your knowledge to the test. Are you ready to see how well prepared you are for the big day? Log into your teacherpreps.com prep account now and take the engineering practices test now.